Hey, back again from where we ended. We are still handling functions. Now, from our previous episodes, the two episodes where we were talking about functions from, we had a pending section under user defined functions. We talked about what we call function prototypes. Okay. Now, we said prototypes, these are declared and defined later in the program. So, our next target is to talk about what we call prototypes. So, I'll type around here, just under the same section. If you have watched this episode, then automatically you must be having this screen in one of those two previous episodes. This is the third episode that is talking about functions. Now, we have said prototypes are declared and defined later in the program. So syntax is of course going to be, we shall have return type, we shall have an identifier, then we shall have parameters, and we shall terminate. So not function prototypes are terminated at the header. Okay, function prototypes are terminated at the header. So it means each time you make a definition, each time you make a declaration, then it means you need to terminate. So assume we had a function which is called int max, and max is having int a, int b, and int c. That is a function. So it's finding the maximum among the three. Okay. Assume we had another function which we can say void line draw. I have a function that draws a line, so I will terminate. Okay, you see that? Then I have a function that I remember we had some questions. Let's check them out. Okay, they were here, this list of questions. I know I've showed them to you in some previous episodes. So the gravitational field of the moon is 17% on. So write the program that calculates the weight of man on. So to do that, let's have a function also that can help us talk about that. Where was I? Okay, so I'm going to say float weight. Okay, what was it? Weight of the man on the moon. So let me call the function weight moon. Okay, and inside I have float w. Assume that way. So all I'm showing you is examples of how to declare function prototypes. Now there is another way this can be done. I can still say int max, then max, definitely it was expecting two parameters. I'll say int guys, that is also a valid one. Okay, the same applies here. This one didn't have parameters, so we can't change that. We can't have another version of it. So still I can say float weight moon, and inside I can say float. Definitely those two are the same, the one for weight moon and the one for max. So any of those two methods can truly work. Now before I do any of these ones here, let me take you back to the previous example that we had. Now in the previous episode we ended with this running practical example, and this example had three functions. So this was pure function 1, and this was pure function 2, and this was function 3. Okay, remember in our explanation I'll be referring you back to all the episodes that we have been watching connected to functions. I said declared and defined later in the program. So I want to show you where the declaration occurs and where the definition occurs later in the program. So since we have a pure function 1 and we have a pure function 2 and 3, so what I'm going to do to simplify life, let me copy. So I've copied. Now I want to return them, I want to convert them into prototypes, assuming I was handling prototypes. Okay, yep, so that becomes a prototype. In fact, let me say here prototype 1. Again, you terminate. This is prototype 2. Again, this is prototype 3. So what will I do? I'll do the same. You see that? You see how beautiful it is? So definition is later in the program. Later means after closing the main. So all, I'll comment here, all function definitions are done after closing the main. So I'll come back here. So when after closing the main, when you come this section, when you come here, then that is when each of them is given a body. But definitions, declarations, are done from up here, the way you see that. Okay, so let me even make the program better. Somewhere here I had another function which is known as line draw. Okay, let me make it a prototype. Here. It's called line draw. Okay, now someone might ask, can't you have a mixture of prototypes and pure functions? Yes, you can, or you can choose to have only one, or you can mix them up. Okay, but in most cases, to me, it appears to be nice and more organized if you use one pattern of declaration. Like you have prototypes, then you define them later. So down here I'm going to define it. So I want to show you its real definition. So when you reach here, remove, okay, the termination, then give it a body. So like this one is going to draw for me a line. So that is the line that I would want each time it's called. You see that? You see that, guys? So it means each time I want to call this function, I'll just say line draw. So back to the program, let me try to implement all this. Around here I make a call. You see that? Definitely after power fan, even around here I can make a call, but don't forget, if you don't terminate, then definitely those are errors. So wow, my program has how many functions? 1 2 3 4 functions. Don't forget, we are trying to use this should not bother you because it was for some other program that we did earlier, but here we are looking at function prototypes. So I have as many as possible, and I've shown you how to invoke. So back again to our compiler. So should try to check and see how we survive. So 3 to the power 4. You see, it draws a line. Okay, it draws a line. How old are you? I'm 90 and my name is Peter. So it says, hey Peter, you are 90 years old, and how are you doing these days? So it draws another line. So basically prototypes work exactly the same as pure functions, but the implementation is what differs. One of when it comes to pure functions, you declare and you define, but when it comes to prototypes, you declare and define later in the program. Okay, now there is something that is really so very important. There is something that is really so very important. Which one were we handling? Okay, it was here. Now I think let me just note here, at the time of calling, I think we talked about that, at the time of calling functions, parameters are passed to the function. So we said if they are passed to the function at the time of calling, then definitely we said they are called arguments. So parameters are passed to the function in any of the two ways. One is by value, and that is what we are doing in all the examples that I've just showed you, and another one is by reference. So please guys, the first assignment for this episode, try to dig deeper about by value and by reference. That will give us something really so nice in the understanding of functions. Now, still around functions, there is something that is so important, which is called recursion. I remember hinting about recursion. Where did I do that from? There was a section where we talked about uses of functions. There was a section where we talked about uses of functions. Where was it? Uses of functions. It is here. we said functions simplify problem solving. Those of you who watched the previous episodes about functions, I talked about that. More so in scenarios of complex problems that require recursive solutions. Then I remember very well, after mentioning the term recursive, I said we shall look at it later in the coming sessions. Now, this is the right time, I guess, where we are talking about what we call recursion. And someone is like, it's a beautiful word, but what do you mean? Now, recursion is implemented in a number of scenarios. Now, when do we call something recursive? Now, we call an object or a function recursive if it contains itself, or if it is defined by itself. I'm saying it again. We call an object or a function recursive if it contains itself. Just listen. I'm not noting anything for now, so that you first understand before we jot down something. Now, recursion is a programming technique. Recursion is a programming technique in which a method or a function makes a call to itself. Right now, I know I'm talking to someone who knows something about programming, more so when it comes to methods or functions. I'm very sure you have watched all the previous episodes before you landed on this one. Definitely you have even already subscribed to this YouTube channel, Programmer's Life. So I'm saying again, recursion is a programming technique in which a method makes a call to itself. Reason: to solve a particular problem. Now, if a method has such abilities of calling itself, then such a method is called a recursive method. Okay, so at this point, something we need to note that makes really a lot of sense. So I'll say recursion is a programming technique. Okay, like I've already mentioned to you earlier, whose correct usage. So it means sometimes, based on the programmer and the way they logically interpret a certain concept, they might misuse. So whose correct use leads to an elegant solution. Think about that. Elegance. An elegant solution to certain problems. Okay, which simplifies programming code and readability. Now, I know someone is very anxious, asking, where is it really applicable? So maybe I can say example of applicability. Example of applicability is the Fibonacci. Numbers. Okay, now someone might ask, you are talking about here Fibonacci, then what does that mean really? Now these are numbers that follow a certain sequence. How better can I put it? Okay, this way I think it will be better. Now these are numbers that follow a certain form of sequence in their generation. Now this sequence goes like this. Each element or each number of the sequence is formed by the sum of the previous two elements. Okay, like let me note, each number in the sequence is formed or is an outcome. Okay, is an outcome of the sum of the previous two numbers. I think that logic is simple now to understand after this explanation. So the concept is the first two elements are equal to 1 by definition, but the first two elements are equal to 1 by definition. Guys, I'm getting these things from my head, so of course I might skip some things, I might miss out on some things, but as I talk too much, I even try to note down some of these. So each number in the sequence is formed by the sum of the previous two numbers. I think that is so direct. But the first two elements or the first two numbers are equal to 1 by definition. That is the policy. Then on the next two, the rule begins to apply. Then on the next two, the rule, which rule? The rule that I've mentioned up, being an outcome of the summation of the two previous numbers. So then on the next two, the rule begins to apply. What do I mean? If I had 1 and 1, then I'll have 2, because 2 is the sum of 1 plus 1. Okay, so I'll have 2, then I'll have 3, I'll have 5, help me there, 8, then 13, then 21, then 34, 21 plus 34, that is 55, 55 plus 34, that is 89, 89 plus 55, that is 144. Okay, I'll end there before I bother my head too much. So that is what we call a Fibonacci sequence of numbers. Don't forget, I'm still under what we call recursion. So the rule or the policy is going to be under Fib or Fibonacci. It's gonna be, if I have f1, okay, then f1 is f2, which equals to 1. So what does that mean? If I have fi, which equals to I minus 1, okay, plus fi minus 2, so the concept goes in. For that matter, it means that I is greater than 2. Now you know, these are some of the moments whereby someone really needs to have an open mind to grasp certain concepts. But of course, like I always tell you, when you watch my videos, it's not the end of the world. Make more research to make yourself better. Definitely, I believe my toolbox really has a lot. That is what I'm trying to share with you right now. So hope these concepts are really driven home now. So let's try to have a method, a recursive method, because this is an example of a scenario that requires a recursive technique if we are handling this programmatically. So let's have a recursive method for finding the nth Fibonacci number. Okay, so I'll say I have a double, and I'll say Fibo. I'll have a double and I'll say Fibo, then I'll have n. Okay, my function is called Fibo, and it is having a single parameter, which is an integer. Okay, so why are we using a double? Of course, we need to span beyond a normal integer if at all we are going to move up to a certain level of sequence generation. So to surety, we need to leave that allowance. So I'll ask myself if, because we shall set an if statement, if n is less or equal to 2. So definitely, like the same way we handled that under what was the example that we had in the previous, it was about factorial. So here definitely we shall return 1. Okay, because if you remember, we said the first two initial numbers, two elements, are equal to 1 by definition. So and we said for I is greater than 2. So if it is less or equal to 2, then definitely we should set a limit. That is why we are returning 1. Otherwise, we continue to make we continue to make a sequence for this case. So here I'll make a call. I'll say by making a self call to the same function. This means we are recursive, so directly to an explanation. So what shall we do? We shall return, my function was called Fibo, so I'll return Fibo into n minus 1 plus Fibo self call again n minus 2. So I hope this is getting really implemented. So ladies and gentlemen, I'm trying to show you what we call a recursive call. So I'm calling Fibo twice within itself. The main function is called Fibo, but inside I'm returning a value still from a call. Don't forget to terminate there, from a call of the same function. So this example shows how simple and natural the implementation of a solution can be when you are using recursion. But on the other hand, it can serve as an example of how attentive we have to be while programming with recursion. That is why up here I said if it is used in the correct way. Okay, if it is used in the correct way, then definitely you're going to have an elegant solution to the problem that you might be handling at that particular time. Okay, so that is really very, very important. But as a programmer, I think it is really so relevant and so important for someone to know the different types of recursion. Wow, programming digs and digs and digs and digs, which is okay because we need to know the language. So types of recursion. For this case, we have what we call direct recursion, and we have what we call indirect recursion. Now, in my first explanation, I was just giving you the general concept of it, but again, we have what we call direct and indirect recursion. So still, when it comes to that, I think it's gonna be the first assignment for us today. So guys, look out for what we call direct and indirect recursion. But again, that is not the only scenario where we have recursive technique. We can have another one, but we did this one earlier, though it wasn't implemented using functions. So this time around we can do the same, but trying to implement functions. So I can say double factor using factorials. So I'll still say int n, we are finding the factorial of a certain value. Still, if you remember, we need to have a terminal so that we don't go beyond the limit. So it means this is called the bottom of the recursion. The same way we have it here, checking if the given number in generation is less or equal to 2, this is the bottom terminal value. Okay, terminal section or terminal condition. So it's called the bottom of the recursion. There should always be, in the recursive call, those number of times in which you call the function, you command the function to call itself continuously, then of course there has to be a limit. It cannot do it forever, so we check. That is why here we shall say if n is equivalent to 0, definitely the programmer has already noted what do we return, because we said it's the limit, return 1. Otherwise what is going to happen, we shall make a recursive call, okay, function calling itself. So what shall we return? We shall return n, what was the name of the function? We have factor then n minus 1. If you don't forget how the method works, please look out to our previous episodes that we chatted with. So okay, so this can be implemented if at all you want to in the program, and automatically it will work for you as you expect. Okay, it will work for you as you expect it to be done. Now for any questions from what we are handling right now, I would love that people reach me out on my WhatsApp number +256 751824973. Subscribe to my YouTube channel, Programmers Life. Yep, and activate notifications for any episodes that will be dropping around. So I sign out.